Okay, now we're taking a look at product to sum identities, and these are actually quite simple, and I really like these. What we're looking at here is this format, and notice in this example it's a sign. And so what I do with this product is I'll match it up with my product to sum identity here, and I only see one of them that says sign. So it's this right here, and notice what it says. It says take half of the cosine difference of the angles and then add the cosine sum. So let's go ahead and take a look at that. All right, so let's see here. If I have this as my A value and this is my B value, then my answer here will be that this is half, and then we put our square bracket because it's a product, and we're going to say cosine. Okay, and it says first the difference, A minus B. So 19 take away 31 happens to be negative 12. All right, so I'm going to write negative 12 here for a second, but that's going to change in just a minute. So I'm going to erase that. All right, and then I'm going to add in the cosine of the sum. So now 19 plus 31 is 50, and that one's okay. And I'm going to close this out. Okay, now notice cosine of negative 12 looks kind of funny there. So let's go ahead and take a look at our negative angle identities for a second. And if we notice, if we have the cosine of a negative angle, a negative theta in this case, well, it's the same as a cosine of theta. All right, so we're looking at this, we're looking at this. What this tells us is that this function is said to be even. All right, so I'm going to zoom out of this. All right, let me just get rid of this real quick. I'm going to zoom out here, and I'm going to go ahead and change this negative 12 to a positive 12, because I know that cosine is even and it's not going to be negative in this case. So to answer this question using the product to sum identities, well, that's it. That's all there is to it. All right. So let's go ahead and take a look at another example. All right. So let's take a look at a second example here. Let's say the cosine of 43 degrees. And let's say what? Cosine of 20. How about that? All right. So we've got another A and B situation, and actually let me just change the color on that so that it stands out. A and B, and we have the case of a cosine. So what does that look like to us? This is the cosine case. It's a cosine of the sum and then adding the cosine of the difference, again multiplied by half. So let's go ahead and zoom out for a second and write that down. So again, this is half of the product of the cosine, the product of 1/2 times the cosine of, in this case, A plus B, 43 plus 20, 63 degrees. And then adding to that the cosine of the difference, 43 minus 20, which is 23 degrees. And notice in this example, we don't have to deal with any of this even and odd business. All right, so it's pretty straightforward here in terms of the answer. All right, so there's another example down. I think it's important that we try to hit all of the identities here. So we'll go ahead and try to do that with this next example. All right, so let's see on this next one. How about a cosine sine variation? Let's say cosine of 20 and the sine of 45. All right, cosine 20, sine of 45. Again, I have my A, I have my B here, and I am looking at the cosine sine formula, and let's see here. Let's zoom in. The cosine sine is this one right here, this product. It's the sine of A plus B minus, and this is key, the sine of A minus B. So we're going to take a look at that. All right, let's see here. So let's see, half, and this is a product. This is the sine of the sum, 20 and 45, which is 65 degrees, minus the sine of the difference, which in this case is negative 45 degrees. Now, I'm going to erase that again because we need to change this. All right, but let's keep it there for right now. Let's first take a look at the negative angle identities, and let's see what we get. A sine of a negative theta is equal to the negative sine of theta. So this right here is what we call an odd function. All right, so it's odd, and we're going to use that right now to be able to answer this one right here. So we know that this negative is going to come outside here. All right, so let me go ahead and erase that. Erase this, and I'm going to put another negative sign, in this case, of, what was it? 25, because that's the difference. All right, let's take a look at that. It looks something like that. Well, we have minus minus. In this case, that means plus. So what we're going to do is we are going to add these two, and this right here will be our answer for this example. All right, now let's take a look at one more for good measure. Let's take a look at the last case, or just maybe not necessarily the last case, but how about we throw in some radians. I like that. Radians are always fun because everybody loves fractions. Well, not really. Let's see here. We have the cosine, what could I say? How about 8 pi out of 15? And let's take the sine of pi over 9. I like that. All right, two different denominators. We're going to want to apply the cosine sine formula, which is the one we just did. Not a real big deal that we're going to use it again. They all work pretty much the same way, with the exception of the even and oddness here. But it's not terribly difficult. All right, so let's see what this looks like for us. I'm going to not even worry about adding these fractions just yet. I'm just going to utilize the function or the identity that's over here, and that's this one again. All right, the cosine sine. So I'm going to take half of the sine sum. All right, so don't even worry about it. Don't sweat it. I'm going to write it like this, really simple for you. And we'll worry about adding the fractions in just a bit. All right, so there's the sine sum. We're going to subtract the sine difference. So it looks something like this. Okay, now we close it off, and let's actually do that arithmetic. All right, so let's move this out of the way real quick right there. Let's see here. We have 8 pi out of 15. Now watch what I do. I'm going to do plus and minus because we're doing both right here in this example. And pi over 9. Well, now let's think about what the common denominator is here. Well, 15 and 9, common denominator is 45. So I can multiply this guy by 3 over 3 and this guy by 5 over 5. Okay, so that's going to give me, this is 24 right here, and this is 5 pi anyways, so 24 pi, 5 pi, 24 pi over 45 plus and minus 5 pi over 45. Looks something like that. Okay, so really quickly when we add them, we're going to get 29 pi out of 45, and I don't think we can reduce that. And then when we subtract them, we're going to get 19 pi out of 45. So we get that one right there. So this will come here and this will go there. So our answer for this question here is that it is equal to half of the sine of 29 pi out of 45 minus the sine of 19 pi out of 45. And then we don't even have to worry about negative angles or anything like that. We have our answer. Okay, so these are just a quick look at some of the product to sum formulas and how you use them. Again, like I said before, be sure you note if you're using negative angles or not, even an oddness of these sine and cosine functions and things like that. And again, they have a great application in calculus. So when you get beyond pre-cal, when you get beyond your trigonometry course, you're going to need to know this, and it really will make your life a lot easier. So good luck.